Alright, so today we're going to be sharing a couple properties of lines, especially two lines. So I'm going to go ahead and graph p of x and g of x. So I'll grab p of x first. I'm going to start at -1, go up 2 over 1, 2 over 1, 2 over 1, backwards down, backwards down. So there I have p of x. And then I will graph g of x in yellow. So I'm going to start at 2. I'm going to go up 2 over 2, up 2 over 1. Same thing here. So what you may have noticed is that these lines run very similar to each other. They run kind of like train tracks, you might say. And these ones, as you guys probably remember, are called parallel lines. Something else that you might notice and what makes them parallel is that their slopes are the same. And I know that their slopes are the same because I see the 2 in front of x on both of them. Right? So 2x minus 1 and 2x plus 2 have their slopes in common. So those are parallel lines. And then, as you can probably imagine, we're going to think about a different type of line here. So in h of x, we're going to start at -3, go up 2 over 3, go 2 over 3, backwards and down. Go ahead and graph that line here. Right, so this is h of x here. And then k of x, when we're graphing k of x, I'm going to start at +1. Going down 3, backwards 1, 2, down 3 over 2, down 3 over 2. Whoa. Right, so I'm able to go through each of these points here. And what we should see is that kind of opposite of the parallel lines, these ones do intersect. And they're special because they intersect at a 90-degree angle. Right, so 90-degree angle. That means that each of these is 90 degrees. And it means that these are called perpendicular, as you guys might remember. Perpendicular lines. And they have opposite reciprocal slopes. So for example, see if you can do these as I go. If I have a slope of 1/6, then my opposite reciprocal would be -6 over 1, or just -6. If I have 2 over 3, it turns into -3 over 2. If I have 1 over 7, turns into -7 over 1. If I have -4, then -4 turns into +1 over 4, because this is technically just 4 over 1. So my opposite reciprocals will change from top to bottom. So from looking at a problem like this, it says find the equation of the linear function that passes through the point here and is perpendicular to the graph. So I remember that perpendicular means 90-degree angles, which means that they have opposite slopes. One's going down, one's going up. So if I see here that this line this slope has a line of -1 over 3, then the opposite reciprocal slope, the new slope, would be +3. I'm taking that 3, moving it to the top. The negative is being removed, and the 1 is going to the bottom. From there, I know algebraically they tell me what x is and what one of the y's are. So I have -3 equals my slope of 3. It's going here. M. X would be -2 plus b. 3 times -2 is -6. I fill in the rest of my equation. Add 6 on both sides. It's going to give me 3 equals b. So I know that my equation for the perpendicular is y equals 3x plus 3. So I can double check that this is both going through the point as well as being perpendicular by graphing both of them. So I have positive 3, going down 1 over 3, down 1 over 3, moving backwards as well. So I can see this line is h of x, and I can see that that's going through the point negative, or I know that I want my new graph to go through the point -2, comma -3. So I can see that point there. I can see that my new graph, the one that I've just created, should probably go like right about this way, something around there. So I'm going to go ahead and graph it. I'm going to start at positive 3, and I'm going up 3 over 1, backwards as well. So I can see that it does go through that point that I was hoping it would go to, and it goes in that direction I was thinking it should. Right, so this would be the new f of x. If you were wondering, we probably should write this f of x equals 3x plus 3, because they did tell us that the new equation is f of x. So if they tell you what it is, you can always do it that way. And then finally, we have a second one. It says, find the equation of the linear function f of x. So we know our answer is going to be f of x that passes through the midpoint of this point and that point, and is parallel to the graph of the linear function. And we have g of x here. So it's passing through the midpoint. That means that these are not points that are on the line, but whatever is in the middle of them is. So we could do midpoint, midpoint. What do? Add them up and divide by 2. So I'm going to take -4 plus 2 and divide it by 2. Those are my x values. And then y is 2 plus 4. Those are my y's over 2. So I'd have -4 plus 2 would be -2 over 2 be -1, comma 2 plus 4 is 6 over 2 would be 3. So it says find the equation of the linear function that passes through the midpoint of these things. So it's passing through -1, comma 3. So that is my x and my y that I'm going to use to algebraically find something that's parallel to this function here. So parallel means same slope. So the slope of this one was already 2 over 3. So the same slope is going to be 2 over 3. Now I need to solve it algebraically. So y equals mx plus b. I can see that x is -1. So I'm going to substitute that. See that y is 3. Just substitute that. See that m is 2 over 3. So I'm going to substitute in 2 over 3 plus b. From here, I can multiply these together. I get -2 over 3 plus b equals 3. I'm going to add 2/3 on both sides, which I know is 11/3 equals b. So when I am writing my equation for f of x, I'm going to use the new slope, or the same slope because it's parallel. So 2/3 x plus 11/3. From here, I'm going to graph both of those. So 11/3 is roughly, let's see, 3 and 2/3. It's pretty close to 4. So I'm going to start like right about here, somewhere between 3 and 4. And then I'm going up 2, 1, 2 over 3, 1, 2, 3. Notice that I started in the middle of the point, so I should be in the middle of the point here. And then down 1, 2, backwards 1, 2, 3. Same down 1, 2, over 1, 2, 3. So this becomes